These are the appendices that supports the statements made in particulate matter control for coal-fired power plants presentation. Appendix A is about the quid graph on patents. Our quid inquiry explores the patents in the air quality control system space. Firstly, our search showed that Alstom has the highest number of filing for patents in this space, and they made the applications recently. This shows a strong research and development activity carried out by Alstom. When we looked into the content of Alstom's patents, we saw that 4 out of 7 patents explicitly mention fabric filter technology as a design element. This strongly signals that fabric filter is part of recent research as a preferable PM control technology. Appendix B is on fabric filters. As in any filter process, a dust cake is formed on the filter at one point, and a cleaning system is necessary to get rid of it. The fabric filter can be divided in 3 depending on their cleaning process. 1, 2, 3. During the reverse air cleaning process, bags are cleaned by injecting clean air into the dust collector in a reverse direction. For the shaker, motors shake the top horizontal bar from which the bags are suspended. During the pulse jet process, bags are cleaned by a short burst of compressed air injected through a common manifold over a row of bags. Fabric filter technology uses a fabric filter media to collect the particulate in a flue gas. Such fabric filter media takes the form of long and cylindrical bags. Thousands of these bags are gathered in the pulse valve. Those pulse valves are incorporated into separate and isolatable compartments. Dampers provide the ability to isolate each compartment from the others, therefore allowing maintenance and inspection on a regular basis to take place in a single compartment while the rest of the technology continues to work. In addition, collected particulate from the flue gas builds an ash cake layer over the filter bags that further aids in preventing passage of the particulate through the bags. The ash layer needs to be periodically cleaned, otherwise the pressure drop would exceed the desired limits. Therefore, the filter bags are periodically cleaned. An online cleaning method is used while the filter bags are filtering the flue gas, as well as an offline cleaning method, as some applications within the technology require so. Those cleaning methods are their frequent and crucial to the technology. It determines the typical dust cake depth and in turn affects the resistance to pressure drop, which ultimately determines the draft loss. We stated that the main challenge observed with fabric filters is high operation and maintenance costs. The following table compares operation and maintenance cost of fabric filtered with ESP. We observe that in average, the operation and maintenance cost of fabric filter are twice what ESP cost represents. The data provided here is related to Indian, Indonesian, and South African coal. However, since it appears that the result observed apply in the 3 countries, we can reasonably assume that it is also the case in Asia. Appendix C is about ESP. The most basic precipitator contains a row of thin vertical wires followed by a stack of large flat metal plates oriented vertically. The air or gas stream flows horizontally through the spaces between the wires and then passes through the stack of plates. As you can see, the wires will negatively charge the particles, which will then be attracted to the positively charged plates. So the particles are extracted from the gas flow. Electrostatic precipitators are generally divided into 2 broad groups, dry ESPs and wet ESPs. The distinction is based on what method is used to remove particulate from the collection electrode. Dry ESPs remove dust from the collection electrodes by vibrating the electrode through the use of wrappers. A wet electrostatic precipitator operates with water vapor saturated air streams. The wet ESP is commonly used where the gases are high in moisture content, contain combustible particulate, or have particles that are sticky in nature. Appendix D is about hybrid systems. The official name of hybrid system is Electrostatic Fabric Hybrid Particulate Collector, EFPC, and is currently divided in two types, the hybrid particulate collector and the advanced hybrid particulate collector. The main difference between the two is that the AHPAC has a more complex structure in which the gas flow goes through a porous collecting plate because going through the fabric filter. It is interesting to note that such systems are already being implemented in the US and China. In China, the EFPC used in power plants are similar to the COHPAC type. Zebjon, China FEIDA Environmental Science and Technology Company, has installed several separated and integrated types of EFPC. For the integrated type, the biggest one is used for a 200 MW unit in the Baotou power plant. Since the EFPC systems have been installed on bigger power plants, such as the Jharsuguda power plant of India, which was installed downstream of 6 times 600 MW units. Appendix E is about the future scenarios. The timeline we presented in the last slide incorporates information from several sources and our own sensible judgment. We had to adjust the way we presented the data in order to create a coherent timeline. The percentages of PM control technologies used in thermal power plants in China were worked out from this graph taken from a presentation titled Emissions of Air Pollutants from Power Plants in China. Our scenario 1, S1, corresponds to the PC scenario of this graph, which stands for Alternative Policy Scenario, meaning new air pollution control policies are released and implemented, representing the best case of future environmental policies. For 2005, we presented the usage level as 100% usage of ESP since WET is a type of ESP. We also presented the percentage attributed to fabric filter under the name of hybrid because common practice is to retrofit an FF system into a power plant that uses ESP. Since 100% of power plants in 2005 were using ESP, the sensible judgment to make was that the growing share of FF technology is referring to retrofitting applications. The predictions were made for emission standards in 2020 and 2030 are solely our speculation based on the past actions of China and possible targets they may have for the future. The percentage changes of PM control technology usage we predicted for the S2 scenario in 2020 and 2030 are also solely our speculation since we weren't able to find the relevant data on the web. We tried to be as realistic as possible, but one should be aware that these numbers are not based on any scientific research. Thank you for listening.